Hello everyone. I wanted to solve this problem that got batted around on one of the discussion post threads. It's actually problem 101 from section 5.5 on page 320 of the textbook, but it is so fiendishly delightful that I think it should stand alone outside of any textbook or any edition of any textbook. So let's just give it a name. Let's call it the world's most camouflaged trinomial problem. And the first move in any of these factoring problems is you look to see if the terms have some common factor. And we have 6 terms here, but they don't share a common factor. And so we're stymied right from the get-go. And thereafter, there's really no clear first step to make here, except if these first three terms were standing by themselves, you would immediately say trinomial and you would immediately crack them. And given that I can't see another move to make here, let's just go ahead and do that. Let's just factor those first 3 terms, the trinomial that it is. And so we're looking for the magic numbers that multiply to +4 and add to -4. And those numbers are -2 and -2. They multiply to +4 and they add to -4. And once you find the magic numbers in trinomial cracking, you can immediately factor it. And so this trinomial here will crack as s minus 2t binomial times the binomial s minus 2t, which I'm going to write in shorthand here as simply s minus 2t squared. Now, how does this move the ball forward? Well, at least we've done something. We've done some work on this problem. And now we have a new factor to deal with here too. We have s minus 2t. And so, we look at the remainder and say, do we see that factor, s minus 2t, is possibly existing? And yes, if we pull out a 4 here, and let me do that. Let me factor out a 4. If we factor out a 4 from the next 2 terms, pulling out the 4 here, what gets left behind is a s minus 2t. And so we now see the redundant factor s minus 2t. Of course, I still have this appendage hanging here, this +4. So now, here's the point where in the discussion threads a lot of you said, what? Trinomial? I don't see it. Well, in fact, this is a trinomial, and you will be doing this in a future section of the textbook where we find we reduce equations to quadratic equations. We rewrite them as quadratics, and then we use the tools that we have for solving quadratics to solve those more difficult equations. So how is this a quadratic? Well, here, suppose I said I'm going to do a substitution. I'm going to say u. I'm going to create a variable u, and it's going to stand for s minus 2t. Now, I'm pulling that out of thin air, so to speak, but there's order and reason to my madness here. Wherever s minus 2t appears, I can replace it with u. It appears there and it appears there. So let's do a rewrite here with the variable u. Instead of s minus 2t squared, we're going to have u squared. And then we're going to have +4 times, not s minus 2t, but what s minus 2t is equal to, which is u. And of course I still have this appendage of 4. Now, there is very familiar terrain, a trinomial, and I know you're saying crack it, and of course it does crack rather easily into u plus 2 times u plus 2, or if you will, simply u plus 2 squared. Now, I'm not done because the original problem was in s's and t's, and I created this decree, this order, that wherever s minus 2t was, I would replace it with u. I'm just going to run that backwards. Wherever u exists, I'm going to replace it with s minus 2t to go back to the original problem. So here's u. I'm going to replace it with s minus 2t. Everything else stays the same. So I still have an addition of 2. I still have the opening and closing parentheses, and I still have the power of 2. So essentially, I have factored that 6-term polynomial expression up here. I've factored it into the multiplication of 2 identical trinomials. And if we were to multiply this out, we would indeed get back these 6 terms. But let's just revisit what we have done here. Essentially, I created a trinomial right here by a judicious substitution, and then the trinomial was eminently crackable, and I cracked it, and I went back to the original variables by resubstituting in for u. Okay, so I hope that explains it. The world's most camouflaged trinomial. Who would have thought? I'll be talking to you soon again.